Welcome to BKW Physics. Today we're going to look at the motion of three vehicles, three toys that I have here. And what you need to keep in your mind as you look at this motion is what would a distance time graph of each of these three vehicles look like? Okay? What would the distance time graph of each of these look like? So let's start with the first one. The first one is my toy tow truck here called the Big Pumpkin. It says no job is too large or too small. It reads it right on there. I've had this for 40 years now. So still like to play with this toy, and I want you to watch the motion of this particular toy. It goes past the starting line at a pretty good rate of speed back there and slows down to a stop here. Compare this with my next toy, which I call the Sudden Impact. It's one of those little wind-up toys, you know. So we wind the thing up, we start it here at the start line, and when I let go, it starts going faster and faster and faster. Compare that to what I call the Jeepster. Now the Jeepster is just a battery-powered vehicle with a blinking light. And you can see the Jeepster travels at one continuous speed once you let it go until the batteries die down. So, if you can pan the camera around to the whiteboard here, I've drawn three distance time graphs, or I have three blanks actually on the board. And what we're looking for is we're looking to draw the picture that matches up correctly to each of those motions. So starting with the tow truck, you notice that the tow truck slowed down. Okay? You notice that the tow truck slowed down. In the beginning, the distance was increasing quickly. Every second that went by, it covered a lot of distance. As time went on, though, the truck covered less and less distance until, this should be right like flat up here, until at the end, let's say that was after 3 seconds, after 3 seconds, the distance wasn't changing. It was 20. And if you waited another second, it'd still be 20 because it was sitting there. So the distance was covering ground quickly, and then it went to a stop. Now, in comparison, the Sudden Impact did the opposite thing. The Sudden Impact started like really slow, and then it sped up and went faster and faster and faster and covered more and more ground. So at first, it wasn't doing much, and then as time went on, it ramped up and it covered more and more distance. Both of these are curved, and they're both called exponential, as we've covered in a previous video. Exponential. But then the last one you have is the Jeepster. And the Jeepster was weird because once I turned it on, it just went and just kept going. I got quite a bit more here, another like 2 minutes, okay? So the Jeepster just kept going at a constant speed once you had it rolling. So what that would look like is this. You start at 0 still, but it was a linear graph. Hi Sal, Dixie. And so as time went on, you covered more and more distance, but in a predictable way. Every second, you gained a predictable amount of distance. Does that make sense? I want to hone in on this graph, though, for a minute. In math class, as some of you are aware, you can take the slope of something, the slope of a graph. And I want to particularly take the slope of this graph right here. If you took the slope of this graph, now remember, to get slope in math, you do the change in the y-axis over the change in the x-axis. So on the y-axis, you have distance, and on the x-axis, you have time. And that should look familiar to you because the last video that I sent out to the internet, we did this equation. It was velocity is distance over time. So what I'm showing you now is that if you take the slope of this particular graph, it'll give you the same thing, velocity, that we learned about last time. That's it for today, physics.